Hey guys, the next question on Fourier series is find the half range cosine series of f of x is equal to x minus 1 whole square in the interval 0 to 1. So before going to solutions, please subscribe to our channel. So here interval has no pi terms. The interval is not given in terms of pi. So we have to write interval is given in terms of 0 to x to L, where L is equal to 1, right? So this is 1. And whenever the interval is not given in terms of pi, what will happen to the half range cosine series or Fourier series in general? It will be f of x is equal to a0 by 2 plus summation from 1 to infinity an cos, instead of nx, now you have n pi x by L. Okay, so if the interval is given in terms of pi, L will be pi get cancelled, you will get nx. So if the interval is not given in terms of pi, you have to write it like this, where a0 and an depend upon f of x. Okay, so let's find a0 and an. So what is a0? a0 is 2 by L integration from 0 to L f of x with respect to dx. Okay, this is a0. So a0 will be, I can write it as 2 by 1, right, where L is 1, right, in this case. So from integration from 0 to 1, f of x is x minus 1 whole square. I can write it as x square minus 2x plus 1. Okay, so this with respect to x. So what will I get? 2 by 1 is 2. Integration x square is x cube by 3 minus 2 into integration x is x square by 2 plus integration 1 is x. So this is from 0 to 1. So what will you get? 2 as it is. First we will substitute upper limit in place of 1. In place of x, what will you get? 1 cube is 1 by 3 minus 2 and 2 get cancelled. So 1 square is 1 plus 1 in place of 1, right, in place of x you have to write 1 minus substitute lower limit. 0 cube is 0 minus 0 square is 0 plus 0. Okay, so we will get a0 as 2 into minus 1 plus 1 get cancels, 2 by 3. So a0 value is 2 by 3. So I will write it that here. So a0 is equal to 2 by 3. Now let's find an. Okay. Next, an is 2 by L integration from 0 to L f of x into this term here, cos n pi x by L. L is 1. Okay. Or I'll write it one more time. Okay, so this will become what? 2 by 1 integration from 0 to 1 f of x is x minus 1 whole square or x square minus 2x plus 1 into cos n pi x, L is 1 dx. So this is simply integration u into v. So what is integration u into v? Integration u dot v, when u is a polynomial, is u into integration v minus u dash into the 2 times integration v plus u double dash into 3 times integration v minus dash dash dash. The formula goes on till we get a 0th term. Okay, we will probably get need 3 terms here. So using this formula, what will I get? Integration. So 2 I'll keep as it is, open a big bracket, u into integration v. U is x square minus 2x plus 1 into integration v. Integration cos n pi x with respect to x is sin n pi x by n pi. Whatever the coefficient of x, you have to write it in the denominator. Next, minus, okay, I'll write this here, u dash means differentiation of this with respect to x. Differentiation of x square is 2x, differentiation of minus 2x is minus 2, differentiation of 1 is 0. Then integration of sin n pi x. Integration of sin n pi x is minus cos n pi x by n pi. So this n pi and one more n pi here will become n pi square. Okay, so this is the second term. The final third term is u double dash is differentiation of this with respect to x. Differentiation of 2x is 2, differentiation of minus 2 is 0, and integration of this term, integration of cos n pi x is sin n pi x by n pi, right? This minus sign you have to keep it as it is. One more n pi here, 2 n pi is here, so you will get n pi cube. So this is from where to where? 0 to 1. Okay, so this is how you do integration. Now let's substitute upper limit and lower limit here. What will we get? So I'll write 2, 1 for upper limit. So if you substitute 1 here, 1 square is 1, minus 2 into 1 is 2, 1 minus 2 is minus 1 plus 1 is 0. So this entire term will become 0, minus, if you substitute 1, 2 into 1 is 2, 2 minus 2 is 0. So this entire term will become 0. Okay, it's minus and minus plus, you can write as plus here. Plus into minus, minus 2 sine. If you substitute 1 here, it will be just n pi by n pi cube, n pi cube. So this is the for upper limit. This term is for upper limit. Minus lower limit. Substitute lower limit. Substitute 0 in place of x. This will be 0. This will be 0. 1 into sine. This will be 0. N pi into 0 is 0 by n pi minus into minus plus. If you substitute 0 here, you will get minus 2. Minus 2 cos n pi x will be 0 by n pi square plus into minus minus 2 sine n pi x will be 0 by n pi cube. Okay, so this is upper limit minus lower limit. So sine n pi is 0, sine 0 is 0, sine 0 is 0, cos 0 is 1. So we will only get one term here. What is that? An is equal to 2 into minus into plus minus, minus into minus plus. 2 into 1 is 2 by n pi square, or 2 into 2 is 4 by n pi square. So An we will get as 4 by n pi square. The term we will get in the at last is very small, but we have to do all this integration and evaluation of limits to get this. Now that we have found out a0 and an, let's substitute them here. Now let's substitute a0 and an in place of a0 and an here. So what will we get? a0 is 2 by 3, 1 by 2 into 2 by 3 plus summation from n is equal to 1 to infinity. An is 4 by n pi square into cos n pi x, where L is 1. So I'll write this. Okay, so this 2 and 2 get cancelled. So you can write the final answer is f of x is equal to 1 by 3 plus 4 by n pi square cos n pi x. This is the answer. This is the half range cosine series of f of x. You can even go further one step and expand it and keep like this. So we'll get 1 by 3 here, right? 2 and 2 get cancels. Plus if you substitute 1 in place of here, first I'll take 4 outside. Substitute 1 cos pi x by 1 pi square. So that is pi square. Plus if you substitute 2, we'll get cos 2 pi x by 2 pi square. Okay. Plus cos 3 pi x by 3 pi square. Okay. Dash. This is a series. This is a Fourier series expansion of x minus 1. Sorry. This is a half range cosine series expansion of f of x is equal to x minus 1 whole square in the interval 0 to 1. Okay, if you want to learn more about Fourier series and practice more questions on this, you can check out our VTU M3 course that we have done, which includes all the basics such as integration of UV functions, evaluating limits, till the examination questions. Okay, and also it includes many previous year solved question papers. The link to the course is in the description.